a short video to explain part of how cryptocurrency works. So this is proof of work mining. Um, so in this directory, I've got a couple of text files, block1 and block0, and I also have mined versions of those, and I'm going to explain what those are. First, let's look at block1 mined, because it's kind of easier to understand what's going on when you look at sort of an intermediate state. So in this file, we have a few values. This is the SHA-256 hash of block 0 mined. Let me just I'll do SHA-SUM. The algorithm I'll use is SHA-256. And if I were to hash the file block 0 mined, notice that it has exactly the same hash as this. So this is an example of a hash pointer. And what it does is it makes this block refer back to the previous block. So it's sort of like a linked list where each subsequent item points to the previous item by including its hash. So that establishes the priority or the order in which the blocks come. And in this file, there's also some content. So there's a list of transactions. So Alice is the person who mined this block. I'll say what it means to mine this block in just 1 second. And she gets $100 for doing that, or you can make up your own cryptocurrency token for the currency. And something else happens, which is Bob transfers $50 to Alice. And it's kind of hard to see at the bottom of the screen here, or at the bottom of the file, there is a nonce. So the reason that nonce is there is it's carefully chosen to ensure that the hash of this file is sufficiently small. So you'll notice that if I hash if I hash this file, okay, it begins with 4 zeros in its hexadecimal representation. So that's not an accident. What happened was this program, the miner program, it takes a file and then it adds a nonce to the end, and it just iterates sequentially different numbers until it finds a number that it can append to the file such that the hash of the file will become sufficiently small. So you'll notice that block 0 mined also has a small hash. In this little toy example that I've created, to be mined, what it means is that a nonce has been added to the end such that the hash of the file begins with at least 4 zeros in its hexadecimal representation. So let me show you what block 0 is. Block 0, there's no previous block. This is the so-called Genesis block. Nothing happened previous to this. And Bob gets $100 for mining this block, but notice that this block has not been mined yet. So during the mining process, now let's look at the mined version of that block. The mined version of that block has a nonce at the end, and that's what makes its hash small. Okay? So let's add a new block to this blockchain. So I'm just going to copy block 1, actually block1.text to block2.text, and then I'm going to edit this file, block2.text. Okay. So actually, now I'm going to, should we invent a new person here? Maybe Eve is going to be the person who. So Eve gets $100 for mining this file, for mining this block. Okay. But we actually want this new block, block 2, to come after block 1. So I need the hash of block 1 mined so that I can enforce this requirement that subsequent blocks refer back to previous blocks. So I need to remove this. Ooh, that was more than I meant to remove. Just do this the hard way here. Okay, and I'm going to insert the hash of the previous block, previous mined block. And maybe something else happens in this block. I'm just making stuff up. Bob gives or pays Alice $25, and maybe Alice pays Eve $33. Okay. All right, and so that's the imaginary stuff that happened in this block. Now, this block has not yet been mined. In order to add it to our blockchain, we have to mine it. If I were to hash this file now, it doesn't have a low hash, right? The hash does not begin with 4 zeros. It needs to begin with 4 zeros so that it can be a part of the blockchain. Fortunately, I have a program in this directory called miner.py, and what you have to do in this project is create this file yourself. So if I run this program miner.py on block2.txt, it'll think for a second and doesn't take long. It found a nonce, and it saved the resulting file as this. So this is like the previous file, but now it's the mined version. So if you look at block2 mined, now it includes a nonce at the end. So this miner program, after it found the nonce that it could append to make the hash low, it saved the result as a file. And so now block2 mined is a legitimate addition to the blockchain, at least in as far as the validity check that we're doing here is that the hashes are sufficiently low. Actually, we haven't checked that the blockchain is legitimate in the sense that we haven't followed these hashes back. Like if we were going to validate this blockchain, then we would need to make sure that these previous hashes actually are the hashes of the previous block and follow the process back to the Genesis block. And we would also need to verify that these transactions are legitimate. But we're not going to worry about those complexities now. Basically, what we're doing is we're making just a proof of work tagging program. That's basically what the miner program does. Is you tell it how much work to do, and it proves that it did that much work by appending a nonce with a certain number at the end. Right now, the difficulty level is 4 zeros. So I could append more zeros if I wanted to. I could change that from 4 to 16 or something, and then it would take, a lot longer. Actually, just adding one more zero, I'm not sure. You quickly go from just a couple seconds to like a year or something if you're not careful. But this is so-called proof of work. Because of the random, sort of pseudo-random properties of a secure hash function, changing this nonce is basically like assigning a new random number to the file, which is its hash. So you can prove that you did a certain amount of work by finding one that makes the resulting random number sufficiently low, because it's kind of like a pseudo-random number. So in order to get this lucky, you had to try many times, unless you can break the hash function and do it faster than you're supposed to be able to do it, in which case you should become a Bitcoin miner because you can make millions of dollars. All right, so your mission is to create this program, miner.py, and it needs to work on the command line, so you need access to Linux or Mac command line. And it needs to take the file that it's going to proof of work tag as a command line parameter. If you want to get fancy, you could also add another command line parameter, which is like the difficulty level or something like that. So what I would like you to do is, I guess I'll give you everything that I have here except for the mining program. And you have to supply the mining program, and then I would like you to additionally create block 3, a legitimate addition to this blockchain. And what you need to hand in is a report with screenshots showing that your program works. The program also needs to include your Python code properly formatted and preferably syntax highlighted. I don't want all the indentation to be collapsed. I will definitely subtract from that because my brain will not be able to process your work. And you should also submit a zip of your resulting blockchain folder so I can go in and look at everything. But hopefully, like all other assignments in this course, this is partially an exercise in communication. So your report should prove to me that everything is kosher and your code works as advertised, and you should do that through screenshots.